Hey, welcome back. We are talking about data structures and algorithms. That's what this course is all about. We're going to be looking at taking our lists that we've been working on so much lately, these lists back with an array, and we're going to connect them into the Java framework. So if we adhere to certain rules set forth by the interfaces in the Java program, we can make our list usable by people doing anything where they need to use a list. And so by adhering to this contract, this interface contract, we can make our list really versatile and just be able to sub right into someone's program and replace another kind of list. And I think that's really an important thing, is that we need to be able to make our own data structures. You want to be able to customize your data structure to make it faster and better, over time, and use it and customize it just the way you want it. But at the same time, we got to be able to play well with others. So we're looking at taking our ability to make these custom, we could call them an array list, and we're going to make it play well with the array list that comes from Java. Well, what I have up here is my web page, and I'll include a link in the description for this video. You can find it by simply Googling Jed Wilshire, W-I-L-S-H-I-R-E. And when you go there, you go to Computer Science, and we are in the Advanced Computer Science. And you can find that we have several files here. We're down here in Unit 1, and so we're going to be using a lot of these. But today, I want us to get Collection Viewer and List Viewer, and if you just click on them, they'll come up and you can download them however your browser does it. You could also copy and paste it in your own file, but I'll just save it in my downloads, okay? And we're going to be using those today. So get Collection Viewer and List Viewer, and those use lists and collections that are typed to the Java interfaces. So if we don't abide by our interface contract, then it's not going to work. But the goal is that these should work as well, if not better, than the code that comes with the Java software development package. All right, so in order for us to get along with Java, we need to see what their rules are. What are their requirements? So to do that, the place we need to go is the API. So let's just Google Java API 9. I like that one. I like it because it's got the Java effects built into it still. They haven't removed those. Now they're separate. And it's got a search bar in the upper right hand corner. Well, the first thing I want to look at is collection. So I want to make a collection. A collection is a little bit like a list, but it's even more simple. So let's start with that today, and then we'll move up to making a list. So here's the collection interface, and there's a lot here, a lot of things to do. Look at all this stuff, right? We gotta fulfill all these contractual obligations. Well, it turns out though it's not as bad as it sounds, because we got a nice thing right here called abstract. Here it is, abstract collection. So we're not gonna just directly implement the collection interface. Let's subclass abstract collection. I think we already saw when we were making our integer list, we saw that once you wrote add at index, well, add to the back is just adding at the index size -1. Adding at the front is just adding at size 0. Once you have a couple of these methods written, all these other methods can be written by just kind of building off of them. And it turns out that's exactly the case with abstract collection. If you look at abstract collection, there's nothing in here that's a data structure. It doesn't have an array in it. It doesn't have any of the ability to do the things that we need, but it has all these concrete methods. I mean, this is this is a tough method to write if you were to try to write it yourself. These two array methods, remove all, retain all this stuff, we get all this automatically if we just do a little bit of work. And so we're going to make the backbone, and we're going to borrow all this other stuff that's, we could write it. Most of these methods are not difficult to write, but it would just take time, and it's not necessary. We can still get the customization and the control that we like while, working smarter, not harder. We will find that there are some methods that we could make better. So we may want to override some of these methods. If we say, hey, the way I made this collection, we can look at the methods as written in the Java documentation and say, with the way I've created this data structure, I think I can do that faster and get a better big O time. Well, then great. Well, then we'll do it. So we'll discuss that when it comes up. Well, let's look at this documentation. So it says this class provides a skeletal implementation of the collection interface to minimize the effort required to implement it. Well, that's what I'm looking for. To implement an unmodifiable collection, the programmer needs to only extend this class and provide implementations for iterator and size. Well, that's not a lot of work. The iterator is a bit of work, but size, that's not. But unmodifiable, it's not really that helpful to me. I want to be able to modify the collection, we'll be able to add to it and do things like that. So to implement a modifiable collection, the programmer must additionally override the add method. So the add method is not abstract right now, but it just simply throws an unsupported operation exception. And the iterator returned by the iterator method must additionally implement its remove method. So we could write an iterator that has next and has next, and we could have an unmodifiable collection, which might be useful at times, but we want to make sure it's modifiable. So we're going to have to write a next, a has next, and remove for iterator. We're going to have to write the size method, and we're going to have to write we're going to have to write the add method, because while the add method's not abstract, it's not very useful. Okay, well, let's get to it. Okay, so I just got a package project here called util examples, since we're using java.util. Let's make a class. Now, what I want to do is I want you to call it the kind of these funky names. So I'm looking for collection array, and we'll also make list array. Java calls them just collection and calls it array list. By leaving them kind of reverse name, then we avoid some name collisions, which I don't want to have. So let's call it that, because I need you to call it that for the viewer program that I have. You could always change the name in the viewer program, but it'll just be easier. So collection array. All right, so collection array. First thing that we're going to do is make sure that it subclasses what we want it to subclass. So public class collection array. We're using generics. It's going to extend abstract collection. Now it's not going to know what that is, right? Because that's not in java.lang, right? It's not java.lang abstract collection, it's java.util. So we need to either use its full name or import it. So java.util.abstract collection. Cool. All right. We're now going to start getting that error over and over again, telling me what I haven't done. I haven't done the size method. All right. So we know we've done this before, right? Let's do it again. If you want to write your, our goal here, maybe it would be a good idea to list this in a comment. What exactly is it that we need to do? Well, we need to make the backing array. We need to make it expandable. We need to make the add method, and we need to make it iterator. The iterator is probably still kind of new to you, but you ought to be able to make the basic framework of this class. Why don't you give it a try? Try and do the array, expandable, the expand method, and try and add. And I think that's all that it said, right? Oh, and size. We need to make sure we have size, right? And you ought to be able. That's not hard at all. Okay. So pause the video and give it a try, and then we'll come back and we'll fill it in. All right, let's see how we did. Well, we know what this needs. This needs an array of type object. I'll just call it array, and I need a size variable. Now remember, we're using generics, so we're going to store everything in object, because when you use generics, they have to be at least of type object, so no primitives, right? Once they say what it'll be by putting string or bird or whatever where that E is, then all the E's become that value. We've seen that in the BlueJ workbench. But we don't have to worry about it. We just put the letter E and know that it'll work. Okay, collection array. And I'm just going to say array equals new object, and we'll just say size 5. Okay. All right. And I'm going to be explicit. The default value for ints is 0, but we'll go ahead and put it there anyway. Okay, so we know we need to make an add method. And in order to do that, we're going to need to make an expand. I'm going to make it private. I don't want people, it's going to confuse people to even see that in my documentation. I don't need them seeing it. It's just for me and my code. It's not for them, not for users. So to expand, we make a temporary array that we've been following the rules that we want it to be twice the size of the original. So it just doubles every time. Temp will bracket I will get array bracket I, and then array becomes our new temp. All right, so we've got an expand method that uses neat. All right, we got to write the add method, right? The add method that we're writing is simply this add here. It's not. It's just an add. We can just do a simple add to back. It's not added index or anything like that. So public. Notice though that this add method is a Boolean, so we need to return true if we successfully add. If we were making a collection that say did not allow you to add the same thing twice, like everything had to be separate, unique, then we might return false sometimes. But for us, we're always going to return true. So it'll just be one little extra step. The data value is of type E. Now you might notice the interface has this little lowercase e. I just find that really confusing. It's like EE. So I don't really like to use that. I like to use a full word data, but we can put any word we want there. To match the interface, we just need to make sure that we're public, Boolean, add, and of type E, or whatever letter we put here. Okay, so we know how this is done. If the size is equal to the array's length, that means that our array is all filled up. So expand it first, it'll expand it, otherwise it'll just skip that step. And array bracket size will get the data. Remember, the data must be an object, so it'll fit an array of type object. Increase our size, and in this case we have to return true. So we're gonna return true so that we know that we successfully added it. We're not doing any restrictions on what can go in, so we'll always just return true. All right. What's next? We have to do the size method. Well, that's not a tough one, y'all. Public int size. Okay. Okay, now we have to make an iterator method. We have to make an iterator in this interface. That is a little bit challenging. We've done it once before, I think. So let's do it together. If you want, hey, pause it, give it a shot. Pause the video, give it a shot. But otherwise, I'm thinking you're probably going to need to do this at least one more time with me. So the method is public iterator. Iterator, and we have to, the iterator takes a generic as well, so let's put an E there, and I'm just going to, now we're extending abstract collection If you go back to the API, you'll notice that it is already implementing iterable, or at least it's claiming that we will. So we don't have to explicitly say that. But iterator, remember, you're iterable if you have an iterator. Iterable is in java.lang, but iterator is in java.util. I don't know why they had to put those in two different places, but they did. Probably had a reason. So go ahead and import it. And, oops, I put iterable. Iterator is what I'm trying to import here. Okay, now, so I'm simply going to return an instance of a class, which I'm just going to call it, okay? We'll put our class right here at the bottom. So we're going to make another one of these inner classes. So a class within a class. And in order to make it an iterator, I need to implement it. All right. There we go. Okay, so let's talk about this iterator that we're going to make. Well, we need to have an index that we can just go through the array. It's going to start at, you know, the index 0 and just go down the array and simply return the value as we get to it. Let's do one that doesn't have the ability to remove yet. It's a little challenging, and then we're going to add to that, okay? So to make a simple iterator that cannot remove things, I need an index that my iterator is at, which, you know, upon construction, we'll just start that at 0. We know that we need a public method. I got a private class, but a public method, that's okay. I need the interface has 3 methods. It has next, next, and remove. Remove is default to not supported, so it is actually there. We don't have to write it to make the class compile, but we must write has next and next. So has next. Well, if the index is less than the size, then I'm going to return you have more. Well, I can just say return that index is less than size. So I'm returning true if index is less than the size, meaning that, you remember index is the indice that we're going to be returning next. So if I start at 0, the first index in my array and in my list is index 0, so I'll be returning that. All right, now let's return public E next. All right, so if not has next, what does that mean? Well, if they call next, they really should be calling has next every time first. But if you look at the iterator, let's take a look here. Where is iterator? Iterable returns an iterator. Here's the iterator. You'll notice that next can throw a no such element exception. So I want to throw that. I want to throw what they say, right? So throw new no such element exception. I kind of feel that might be java.util as well. We'll see if it doesn't like it, but I think it won't. All right, so if we get to this point, then that means we safely must have had something to do. So I'm going to say, I can say this, but I can say return array bracket index plus plus. I mean, you might see some people do some jazz like that. So it's going to, the plus plus is going to move the index forward like we need to, but it's going, yeah, I can't find it. And this would need to be cast as well. But it's going to move it forward, but only after it gets the value. So if our index is at 0, it's going to get array bracket 0 and then move it up. Y'all, I want you to know about it, so if you see it, you can interpret it, but don't do it. It's just not good code style at all. So we're going to take some extra time. We're going to say e data cast as e array bracket index then scoot your index up. Always do your plus, plus, minus, minus. All that needs to be on its own line. That's just ugly, ugly, ugly otherwise, and very confusing and difficult to read. And then we'll return the data. But let's go up there and add that import for no such element exception. There we go. So we're importing our errors there. All right. So we've got a workable collection here, but we know what we can't do? We can't remove from our collection, and that's pretty terrible, right? You can't even clear the collection out. It doesn't work. So let's fix this, right? Let's go ahead and add the remove method. So we need to look at the rules for remove. Removes from the underlying collection the last element returned by this iterator. This method can only be called once per call to next. Okay, so what does that mean? Well, removes, the purpose of remove is if you're iterating through this collection, say it's like, you got some, I don't know, you got a collection of items that, gifts that are on your wish list, okay? And all of a sudden you come to a certain, item that you're supposed to get for somebody on your gift list, and all of a sudden you don't like that person anymore. So you say, oh, that's that person, I want to remove it. Or maybe it's on your grocery list. You come to an item and say, oh, I don't need that, I want to remove it. So the idea with the remove is that it's going to remove the last thing you just got back. So, if my collection is got rice, milk, cereal, bread, and I iterate through that, rice, okay, cereal, okay, milk, oh no, I don't need milk, remove. Removes the milk. But if I say, rice, bread, milk, and I remove milk, and then say remove again, well, it's going to say remove what? You remove milk, I can't remove milk twice. So it won't remember and go back. So what we need is a variable to check if we've called next. So I'm going to call this next call. So when the iterator is created, next call will default to false. Let's make it explicit. So when you create an iterator, you didn't call next, so next called is false. Once they call next, then we can set next call to true. Okay, and this is actually quite helpful because we also can't remove something until we've called next at least once. So this prevents you from calling remove more than once in a row. You also can't call remove until you've actually called next. So public, this one's a void remove. And what we're going to say is that if not next called, we're going to throw new illegal state exception. And I'll explain. No call made to next. All right? So as long as they've called next, then this error will not occur. All right, well, so how do we remove? Well, we're basically removing at an index here. We've written methods like that. What index? Well, the index we're in right here. So we're going to say for int I equals index, I less than size, I plus plus. So what I'm going to do is I'm going to start at the index that I'm on right now. This might require a little bit of thinking for a second here. So let's say our list is A, B, C, D, E, F, G, H. And so what's happening is your iterator starts at the beginning. You say, all right, iterator next, and it returns an A. Iterator next, it returns a B. Iterator next, it returns a C. Iterator next, it returns a D. And now I want to remove that, right? The index of our iterator is always at the index of the value that will be returned with the next call to next. So after I called next, my cursor, I hope you can see that little blinking red cursor. So after I called next, I got the D returned to me. My cursor is sitting on the E. What I want to remove is actually behind my cursor, okay? So I am going to have to start at the current index and I could do it in a couple different ways, but I'm gonna write over the index before it. All right, so what's going to happen is wherever that cursor is right now, so, you know, like I said, we start at A, we say next, we say next, we say next, we say next. Okay, I don't like that D, I want to get rid of it. My cursor is currently on E, so what I'm going to do is write that backwards and pull everything back, which is actually going to leave a duplicate here at the end. But when we decrement size, it won't be there anymore for us. All right, so that's going to take care of overwriting it all. Make sure you decrease your size, for crying out loud, that would be terrible. And we need to make next calls equal to false, because you can't remove twice. But there's one more thing that's so important that we got to remember. All right, so let me do this again. So A, I know you're sick of these letters. A, B, C, D, E, F, G, H. I'll space them out a little bit. I don't know if that'll help. All right, this is index 0. This is index 1. I know there's like a bunch of errors because I didn't know what I'm doing, but it's fine. So just imagine that we just called next and it returned a D, okay? And so that means that our cursor is right here at index 4. Well, we just did all this stuff here, and we took this E, we copied this E over where the D is in this for loop. Then the E gets an F, the F gets a G, the G gets that H, the H is still there in the memory of the computer, but we've removed access to it. So it's essentially gone. But where was the cursor? What index is the iterator at? Well, it's at index 4 still. A call to remove should not affect what I get on the call to next. So just to review, when I had the D there, okay? A, B, C, D. One more time. So the cursor is right here at 4. I'm going to put this little I'm going to put these little square brackets around them so you can see it. So that's the index that my iterator is at. The last thing it returned to me was the letter D. I don't like it anymore. I want to get rid of it. When I do that, everything squeezes down. So the E is now at index 3, right? But my index for my iterator is still at 4. And so if they called next, they would get the F. The next thing we were supposed to get was an E. So that's a problem. So what we need to do is we need to move this back. We need to move it back. So I'm going to say index minus minus. And if you don't do that, and I would say probably 85% of the time I make an iterator and I write remove, I mess up the index. And you'll do things like call clear and only half your elements are cleared because you skipped over every other one. Removing in an array list is just, it's just yucky. But with practice, we can all get better, right? Okay, so I think we've got everything we need. We've got an iterator, we've got size, we've got add expandable. We should be good to go. So we can test this out, right? We can use our collection. I do want to go ahead and show you what this would look like. Let me say integer. Look at this. This is kind of cool. Look at all these methods I have. There's my iterator. I made that. I feel special. I've got remove a specific object. Ooh, right? This is really neat. So if we, let's add some things. Add 9. Okay, thank you. That's right. It's going to return true. I'm not worried about adding it, but it's going to tell me because I said it would. 13. Okay. Okay, so some things require arrays, right? So you're in the situation, you're like, man, I really need an array. So don't worry, they wrote it for you. They use your iterator, and you can say, boom, give me back an array of objects. Isn't that cool? And there they all are. Notice the size is exactly the size of my collection, so it kind of makes that array the right size. There is another method that actually can give you an array of the type that you want. But you have to supply it with an example array. So like I'm using integer, so I'll just say new integer. And most people just say size 0. because it just gives you a brand new one of the right size. And you can see there they are, but now they're of type integer, which is kind of cool. So yeah, we inherited a lot of neat stuff, right? We can go through here, and you should go through there and practice using the iterator and seeing how that works. But I want to show you how to use this viewer. So I'm going to go here, and I'm going to go to my downloads, and I have a collection viewer, okay? So if you look at the code, you can, it's kind of lots of graphic-y stuff, but here's the key right here in the start method. We're going to instantiate collection array, so that's why we had to call it that. If you call it something different, you need to go and change that. But that's the only line where it says it. All right, well, let's give it a try. I'll just use this thread as fine. Okay. So the idea is this is supposed to kind of give you a more of a visual understanding of how the behavior is. So this is more abstract. This is not letting it. This is not like when we inspect and we really see the backing array. I just want you to see how it would behave to someone. So and the other thing that's cool is that in order for this to work, it has to implement the collection interface from Java, because that's how it's typed. Otherwise, if it didn't, it would not work. So let's put some stuff in here. Ape. Bird. They're all strings, so it doesn't really matter. Cat, lion. Oops, I misspelled lion. You can just put in some random letters or whatever. All right, well, let's iterate our collection. And there it is, right? So this actually is showing you what's going on, but I want you to see what's in this cell here is what's been recalled from next. So if I say next, you could see where that cursor is. Now the cursor, that bar, is moved to in front of bird because we returned ape. There's bird, there's cat. I already have a lion, so let's remove that cat. I remove it, and did you see how everything, including the cursor, had to move back? And if we didn't write that right, you would see that cursor in the wrong place. You know, we got the has next. We could start the iterator over. This one here, I believe we can actually add during the iteration. Now, the other ones you can't, but, oh, I don't know, give me another animal, pig. And you can see it just adds it right there to the back. So, pretty neat, huh? Okay, so that's, and again, that only works because you'll notice that it's a collection, all right? That's what we're using, a java.util.Collection. So it doesn't play well with this other graphics program unless you wrote it correctly, but you did all the backing stuff.